So in our last video, we had a set S with the members, the letters A, B, C, and D. And we wanted to find out how many permutations there are of the members of this set when we're choosing from all of them without replacement. In other words, how many arrangements are there of all of the members in this set without replacement? So in that example, we found that we had 4 possibilities for the first, 3 for the second, and we were using the multiplication principle. We had 2 for the second last letter, and then 1 for the final, which was equal to 4 factorial. And that was the notation that we used for 4 times 3 times 2 times 1. It's 4 factorial. So in this example, we are going to extend the set a little bit, add on E and F, and we want to find out how many 4-letter words we can make. And we use words in quotation marks because they're not going to be real words. So one possible word would be A, B, D, and C, or F, C, D, and A, or B, A, C, D. So to find out how many possible such arrangements there are, we use the multiplication principle again. So if we want to choose one letter from any of these 6 letters, we have 1, 2, 3, 4, 5, 6 possibilities. And then we take away 1 from our pool of letters. Then we have 5 choices for the next. Again, we're using the multiplication principle. Then we have 4 choices, and then 3 for our last. So the number of numbers here is going to be equal to the number of places we have here. So this is equal to 360, and it is not equal to 6 factorial. The reason that it's not equal to 6 factorial is because if we were choosing 6 letters, 6-letter words from these 6 letters, then we'd have 6 times 5 times 4 times 3 times 2 times 1. But because we're only choosing 4-letter words, we have 6 times 5 times 4 times 3. And there is also notation for this number here. Is going to be 6p4, which is read 6 permute 4, and that's equal to 6 times 5 times 4 times 3 equal to 360. There is a general formula for permutations, and to use the notation we had above, NPR, which is also equal to the notation in some books, N above, permute or, and that is equal to N times N minus 1 times N minus 2 times ... which means fill in the pattern, down to N minus or plus 1. So if we look at the example from above, we had 6 permute 4, and 6 is our N, 4 is our OR, so 6 is the number of objects we're arranging from, and 4 is the number of places in the arrangement. So we had 6 times 6 minus 1 times 6 minus 2 times ... times 6 minus 4 plus 1. So that's going to equal to 6 times 5 times 4 times ... 6 minus 4 plus 1 is going to be 3. So this here becomes kind of redundant, this pattern thing. So we have 3, which is equal to 360. And just say if we were using 6 and we wanted to permute 6 objects of the 6, then we'd be using all of them, which would be 6 times 6 minus 1 times 6 minus 2 times ... times 6 minus 6 plus 1. So hopefully you can see where this is going. 6 times 5 times 4 times ... times 1, which is equal to 6 factorial.